Hello and welcome. In this video, we're going to describe pairs of angles. Our objectives are that we can define and identify supplementary and complementary angles, that we can define and identify linear pairs and vertical angles, and that we can define and apply definition of angle bisector. So let's go ahead and jump in. Let's start with our vocabulary. The first word we're going to define today is complementary angles. Two positive angles who have a sum of 90 degrees are called complementary angles, or they are the complement of one another. So any two angles that add to be 90 degrees. So here, angles 1 and 2 are forming this right angle. Here, 20 and 70 makes 90. So these two angles are complementary angles. We're also going to talk about supplementary angles, and supplementary angles are angles whose sum is 180 degrees. And we would call one the supplement of each other. So angles 3 and 4 are supplementary, 115 and 65 are supplementary. So complementary angles are angles that add to be 90 degrees, and supplementary angles are angles that add to be 180 degrees. And one of the ways that I help remember the difference between the two is that a complement, this word complementary, kind of sounds like the word compliment, like when you say something nice to someone else. So I always remind myself that a complement is always right, like a right angle. That might be something that helps you remember the difference between complementary and supplementary. The next word is adjacent. So up here we had complementary angles and supplementary angles that were sharing a side, that were touching or connected to each other. We also had complementary and supplementary angles that were completely disjoint, not connected at all. And there's a word to describe this type of relationship, and that is called adjacent. So adjacent angles are angles that share a common vertex and a side, but they don't have any points in common. So they have a common vertex and they have a side that they have in common, but they don't have any overlapping portion of their angle. So similarly, a non-adjacent angle is an angle that doesn't have a common vertex and side. So these are non-adjacent angles. They're disconnected. When I think about the word adjacent, I think about touching. Like they are angles that are touching. They share a side and a vertex. Our last two vocabulary words are going to be linear pair and vertical angles. A linear pair, and I love that the word line is within that. A line pair, a linear pair are two angles that form a straight line. So they're going to be adjacent angles, and they form a supplementary angle, because what is this type of angle called? It is a straight angle. So a linear pair is just two angles that form a straight angle. They are adjacent, meaning they have this common side, but they also together add up to be 180 degrees. That is a linear pair, a pair that makes a line. And lastly, vertical angles. Vertical angles are angles that are formed by two pairs of opposite rays or two pairs of lines. And the vertical angles are the ones that are inside the V that are opposite each other. So I like to think of these as V angles. They are the angles that are opposite each other or diagonal from each other within. So here we have 3 and 6 are vertical angles, and 4 and 5 are vertical angles. So now that we've defined our different types of angle relationships, let's go ahead and tie that back to what we already know about angles. Okay, for our first three examples, we're going to be looking at this diagram here. We're going to identify a pair of complementary angles, supplementary angles, and adjacent angles. So remembering that a complement is always right, we're looking for two angles in this picture that add to be 90 degrees. So those two angles are going to be the angle that's 37 degrees and the angle that's 53 degrees. And as we learned in the last lesson, we can define this angle as BAC or as angle CAB, so angle BAC. Over here, we could call this angle RST or angle TSR, or we could just call it angle S. Now for supplementary angles, we're looking for two angles that add to be 180 degrees. So I'm looking at these same angles and I see 127 and 53. That's going to give me a sum of 180 degrees. So angle CAD or DAC. And again, angle S, or this time I'll call it something different, angle RST. And then for adjacent angles, I'm looking for angles that share a side or a ray. So here, AC goes with angle BAC and angle CAD. So those two are adjacent angles because they share a side, angle CAB and angle CAD. The side that they share is side AC. All right, for our next example, we're going to be looking at the diagrams over here. We're going to be given information about angles 1 and 2 and 3 and 4, and then we're going to use the diagram to answer the questions. So if angle 1 is a complement of angle 2, and we're given the measure of angle 1, we're going to find angle 2. Well, let's start by just writing out what it means to be a complement. If something is a complement, that means the measure of angle 1 plus the measure of angle 2 is going to equal 90 degrees. That's the definition of a complement. If I plug 62 in for 1 using the substitution property of equality, then I can get this equation, and then I could subtract 62 on both sides, the subtraction property of equality, which would give me that the measure of angle 2 is equal to 28 degrees. So even though we're not writing the justifications next to each step, being able to think through it is what allows you to really get better at proofs, and that's a really important concept in geometry. So go ahead and pause the video and see if you can work through number 5 on your own, noticing first that we're now talking about angles 3 and 4 being supplements or being a linear pair. Then unpause the video and see how you did. So we can start by using the definition of supplementary to say that the measure of angle 3 plus the measure of angle 4 is going to be 180 degrees. Then we can substitute in that angle 4 is 47 degrees. And then we can use the subtraction property of equality on both sides to get that we have 133 degrees is our supplementary angle. And we can always double check that this is right by adding these two things together and making sure they do in fact give us 180 degrees. Let's look at another example. All right, for numbers 6 through 12, I'm going to encourage you to pause the video and try them on your own. On number 9 and number 12, you're actually going to need to draw your own picture, but for 6 through 11, not counting number 9, you're going to use the diagram to the left. Go ahead and pause the video and work through these on your own. Then unpause the video and see how you did. All right, first up, complementary angles, two angles that add to be 90 degrees. We can write angle FGK and angle LKG. Those add to be 90 degrees. Name a pair of adjacent angles. So angle FGK and angle HGK share the side GK, and they don't have any points inside that they share. So angle FGK and angle HGK are adjacent angles. Supplementary angles, two angles that add to be 180 degrees, while 131 and 49 add to be 180 degrees. So angle HGK and angle LKG. Number 9, we're going to draw our own little picture for, but it says angle 1 and angle 2 are complements. So they're going to add to be 90 degrees, 1 and 2. If the measure of angle 2 is 5 degrees, find the measure of angle 1. Well, the measure of angle 1 plus the measure of angle 2 is 90, and we're substituting in 5. So the measure of angle 1 plus 5 is 90. So the measure of angle 1 is 85 degrees. For number 10, it asks, are KGH and LKG, so KGH and LKG, are they adjacent angles? And they are touching, but they share all of this space inside. And that means that they share portions of their angles, so they know they are not adjacent angles. Similarly, angle FGK, and angle FGH, well, they share a whole portion of an angle, so those are also not adjacent angles. So remember, adjacent angles don't share any points inside the angle itself. For the last problem, we can draw a picture and set up our supplement statement. We can substitute in what we know, and then we can subtract to find that the measure of angle 4 is 32 degrees. All right, let's look at some different types of examples. These last 4 problems are a little bit more challenging, but I encourage you, if you feel up for the challenge, to pause the video and try and work through them on your own, or watch the beginning and then pause the video and see how far you can get. For number 13, when viewed from the side, the frame of a ball return net forms a pair of supplementary, so that's a key word there, supplementary angles, supplementary meaning they add to be 180, with the ground. Find, the thing I'm supposed to find, the measure of angle BCE and the measure of angle ECD. Well, I know that the measure of angle BCE plus the measure of angle ECD is equal to 180, since that's what it means to be supplementary. Then I can substitute in what I know. This is 4x plus 8, and this is x plus 2. That's going to equal 180. Then I can combine like terms. Then I can subtract 10 on both sides. And then I can divide by 5 to get x equals 34. Now, don't forget, this question did not ask us to find the value of x. We needed the value of x, but what we are being asked to find is the measure of angle BCE and the measure of angle ECD. And I'm actually going to find ECD first because it looks a little easier. 34 plus 2 is going to give me the measure of angle ECD, which is going to be 36 degrees. And then angle BCE, I can either find by plugging 34 in for x or by subtracting 180 minus the angle that I already found because they are supplementary. When I do that, I'm going to get 144 degrees. All right, for number 14, we're looking at complementary angles. So I'm going to start by writing out my angle addition that these two angles add to be 90. Then I'm going to substitute in what I know to be true for each of those angles and solve for x. So pause the video and try that part on your own. And there we have the work for x. And then we're going to go ahead and plug those back in. The measure of angle LMN is 4x. 4 times 7 is 28 minus 2. So the measure of angle LMN is 26 degrees, which means the measure of angle PQR is 90 minus that, or is 9 times 7, which is 63 plus 1, which is 64. So here I have my two angle measures. Let's look at our last two examples. All right, I'm really going to encourage you on these last two to pause the video, identify or find what's being asked, and then unpause the video and see how you did. Okay, for number 15, we're first being asked to find linear pairs. So if I'm looking for linear pairs, I'm looking for two numbers that form a straight line, like angles 1 and 4. I'm going to write linear pairs. Also, angle 4 and 5 are linear pairs. In all the other circumstances, it's going to take 3 different angles to form a linear pair. So that would make it not a pair because that would take 3 angles. The other thing we're being asked to identify are vertical angles. So vertical angles are going to be diagonally across from each other, like angles 1 and angle 5. And I believe that's the only vertical angle that we have because it needs to be formed by the same 2 lines or segments. So here are the 2 lines that are forming those vertical angles. Okay, last but not least, number 16, 2 angles form a linear pair. So I'm going to just go ahead and draw what that means. 2 angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. So if this angle is x, the other angle is 5 times as big, which would mean that it's 5x. Find the measure of each angle. Draw a picture. So here's my picture. I know that if it's a linear pair, that means that these angles are going to add to be 180. So 5x plus x is 180. So 6x is 180, which means that x, 180 divided by 6, is going to be 30 degrees. And 5x, which is the other angle, 5 times 30 is going to be 150 degrees. So the angles are 30 degrees and 150 degrees. Let's go ahead and wrap up this video. And here we go. In this video, we focused on defining different relationships between angles, supplementary, complementary, linear pairs, vertical angles. And then we identified those types of angles and their relationships from diagrams, and we used given information to solve for angles using those vocabulary terms. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.